Hi, so today we're going to look at solving trig equations in general form. So we're only going to do the basics, but we are going to use some of the knowledge that we learned back in graphing. So the first thing we're going to do, it's going to give us a trig equation. Your goal is to isolate the trig function. So notice here we're going to add 1 to both sides. So we get 2 sine x is equal to 1. And then we're going to go ahead and divide by 2. So sine x is equal to 1/2. So now you're going to have to think about which angles on my unit circle that will give me a positive 1/2. So because this is positive, remember all students take calculus, sine is positive in quadrant 1 and in quadrant 2. And the family that will give me 1/2 is a pi over 6, because sine of pi over 6 is 1/2. And this one would be 5 pi over 6. So our answers will be pi over 6, and x is equal to 5 pi over 6. And that's only on the unit circle. But because they want the general form, they want all of the angles that land on pi over 6 and all of the angles that land on 5 pi over 6. That means that, remember, that we need coterminal angles, and the period for sine is 2 pi. So we're going to do 2 pi times n being the revolutions. So n is an integer, okay? And we're going to do plus 2 pi n on this one. That will give us all the angles that land on pi over 6 that have that same terminal side, and 5 pi over 6. So that would be both of them, and that would be the answer. Let's look at the next one. So in the next one, same thing, we want to isolate the x, so this would be a negative 1/2. This time, because it's negative and all students take calculus, that means it lands in quadrant 3 and 4. The family is pi over 6, so this would be 7 pi over 6. And 11 pi over 6. So that means x is 7 pi over 6 plus 2 pi n, and remember n is an integer. Those will give me all the angles that have this terminal side that land here. And then x is equal to 11 pi over 6 plus 2 pi n. That will give me all the angles that will land here that have that same terminal side. So my final answer would be these two. Good job. Let's keep going. Let's try the next one. So the next one, notice that we have two cosine functions. So we, just like in algebra, you want to make sure all of them are on one side. So 3 minus 1 is 2. So cosine theta minus 1 is equal to 0. Now we are going to isolate the trig function. So we're going to move the 1 over. We're going to divide by 2. Now again, cosine is positive. Remember, all students take calculus. Now it's in quadrant 1 and in quadrant 4. And the one that gives me 1/2, the family would be pi over 3. And this would be 5 pi over 3. But because I want all the angles that have that same coterminal, that means theta would be pi over 3 plus 2 pi n. N is an integer, remember. And theta is equal to 5 pi over 3 plus 2 pi n. So that would be both my answers, because those are the two that are on the unit circle. And when I add the 2 pi n, will give me all of the angles, not just the ones that are on the first revolution. Okay, let's look at the next one here. In the next one, the trig function here is by itself, but I have this square. So I do need to take the square here, the square root. So this would be plus or minus, don't forget, square root of 1 over 2, which is sine of theta plus or minus 1 over square root of 2. We do want to rationalize it, so it makes it easier for us. So this would give us sine of theta plus or minus square root of 2 over 2. Now, where in all students take calculus, I need all the positives and negatives. So that means we're looking for all of the angles that are on my unit circle that will give me square root of 2 over 2. Well, in this case, the family would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, there's different ways to do it. I'm going to go basic here, and I'm just going to write all of them. And remember the sine function, it repeats itself every 2 pi. So to get all the angles that have this one, I'm going to add 2 pi n. So my theta would be pi over 4 plus 2 pi n. Theta is equal to 3 pi over 4 plus 2 pi n. Theta is equal to 5 pi over 4 plus 2 pi n. And theta is equal to 7 pi over 4 plus 2 pi n. Now, there is a shorter way to write this, but for right now, for us, I do want you to write all of these because it's going to make it easier for us. And that would be the answer. That's all of the angles that would be a solution to this equation. Okay, let's try the next one here. Okay, another square. So we're going to first isolate the trig function. So 4 sine squared x is equal to 3. We're going to go ahead and divide. And then we're going to take the square root. So plus or minus square root of 3, and the square root of 4 is 2. So again, we are looking for all of the angles that are in all the quadrants here. But that will give me square root of 3 over 2. That would be the family of pi over 3. So this would be pi over 3. The next one here would be 2 pi over 3, 4 pi over 3, and 5 pi over 3. So my x here would be 2 pi over 3 plus 2 pi n. X is equal to pi over 3 plus 2 pi n, because I forgot to do that first one. X is equal to 4 pi over 3 plus 2 pi n. And x is equal to 5 pi over 3 plus 2 pi n. And remember, n is an integer. It's our revolutions here. So our final answer would be all 4 of these. Again, there is a way to write it in less than 4 equations here. We can write them in 2, but for us, we're going to write it in this form just to make sure that we end up kind of working in simplest forms here. Okay, let's look at the next one, solving trig functions in general form. Okay, so again, we're going to isolate the trig function. So we get 2 tan x is equal to -2. We're going to divide, so we get -1. So if you remember, -1 would be in quadrant 2 and in quadrant 4. Okay, so we can actually work this out in 2 different ways. We're going to keep, remember with the tangents, notice here they are across from each other. So because they're across from each other, I'm just going to write it once. So the family that will give me that, remember it's the pi over 4. So this is 3 pi over 4. And this would be 7 pi over 4. Now, I'm not going to use both of them for tangent because they are right next to each other. Remember at the top I said there is another way. So because they're across from each other, I can use the first number and just put plus pi n, because notice this is 180 degrees. It's pi degrees here. And n is an integer. So notice that if I put n to be 1, I'll end up with the 7 pi over 4, because pi plus 3 pi over 4 will give me the 7 pi. So when it's tangent, we usually just use the one that's right across from it and then just put plus pi n. Good job.